The cosmos beckons, filled with mysteries waiting to be unraveled. Today, we stand on the precipice of a new era in space exploration, one where artificial intelligence takes center stage. AI, with its ability to learn, adapt, and operate independently, promises to revolutionize our approach to exploring the cosmos. Imagine probes navigating the asteroid belt, their onboard AI making real-time decisions to avoid collisions and collect valuable data. Picture drones soaring over the Martian landscape, their cameras capturing breathtaking images and their instruments analyzing the composition of the soil. This is the future of space exploration. A future where AI-driven probes and drones become our eyes and ears, our emissaries to the stars. Space is vast, unforgiving, and inherently dangerous. For humans, venturing beyond Earth's protective atmosphere presents numerous challenges. The distances involved are staggering, requiring years of travel time even at incredible speeds. Communication with Earth becomes increasingly delayed the further we travel, making real-time decision-making impossible. To truly explore the cosmos, we need machines that can operate autonomously, making decisions and taking actions without direct human intervention. AI-powered probes and drones can be programmed to handle a wide range of tasks, from navigating complex environments to collecting and analyzing data. They can withstand extreme temperatures, radiation, and other hazards of space. At the heart of these autonomous explorers lies the power of artificial intelligence and machine learning. AI, in its simplest form, refers to the ability of a computer or machine to perform tasks that typically require human intelligence, such as learning, problem-solving, and decision-making. Machine learning, a subset of AI, allows machines to learn from data without being explicitly programmed. In the context of space exploration, this means that AI-powered probes and drones can adapt to unexpected situations, improve their performance over time, and even make scientific discoveries that might have eluded human scientists. Imagine a probe analyzing the geological formations on Mars. As it gathers more data, its machine learning algorithms identify patterns and anomalies, potentially leading to the discovery of evidence for past life or valuable resources. Robotic probes have long been the workhorses of space exploration, venturing far beyond our planet to gather data and send back stunning images. However, traditional probes have limitations. They are often pre-programmed with specific trajectories and tasks, limiting their ability to adapt to unforeseen circumstances. AI-driven probes, on the other hand, possess a level of autonomy that allows them to make real-time decisions. They can adjust their course to avoid obstacles, identify and investigate interesting features, and even choose the best locations to collect samples. Drones, with their agility and maneuverability, offer another exciting avenue for exploration. Imagine swarms of drones deployed on Mars, mapping the terrain, searching for signs of life, and even identifying potential sites for future human settlements. Reaching for the star's advanced propulsion systems. Exploring the vastness of space requires overcoming the tyranny of distance. Traditional chemical rockets, while powerful, are limited by their fuel capacity and the time it takes to reach their destinations. One promising area of research is ion propulsion. This technology uses electric fields to accelerate ions, creating thrust and propelling the spacecraft forward. While ion thrusters provide lower thrust than chemical rockets, they are far more fuel efficient, allowing for sustained acceleration over long periods. Another intriguing possibility is the development of fusion-powered spacecraft, which holds the promise of enabling us to reach other star systems within a human lifetime. Building beyond Earth 3D printing in space. Establishing a permanent human presence in space will require innovative construction techniques that minimize the need to transport materials from Earth. This is where 3D printing, also known as additive manufacturing, comes into play. 3D printing involves building objects layer by layer from a digital design, using materials like plastics, metals, or even lunar or Martian regolith. Imagine a future where robots equipped with 3D printers land on the Moon or Mars and begin constructing habitats, landing pads, and other essential infrastructure before human arrival. 3D printing in space reduces the need for costly and time-consuming launches from Earth and allows for on-demand manufacturing of customized parts and tools. The power of many swarm technology and collaborative drones. In nature, swarms of insects or birds can achieve remarkable feats of coordination and efficiency. Similarly, in the realm of space exploration, swarm technology holds immense potential. Imagine deploying swarms of small, interconnected drones to explore a planet or moon. These drones, working collaboratively, could cover vast areas, collect data from multiple perspectives, and even perform complex tasks that would be challenging for a single, larger spacecraft. The key to swarm technology lies in the ability of the individual drones to communicate and coordinate with each other. Space is a harsh and unforgiving environment. Extreme temperatures, radiation, and micrometeoroids pose constant threats to spacecraft and their delicate instruments. To ensure the longevity and success of future missions, it is crucial to develop probes and drones with advanced self-repair capabilities. Imagine a probe experiencing a technical malfunction millions of kilometers from Earth. Instead of relying on human intervention, the probe could diagnose the issue using its onboard AI and then use three-dimensional printing to create a replacement part. This ability to self-repair would significantly extend the lifespan of missions and increase their chances of success. Future probes and drones will need to be designed with energy efficiency in mind, utilizing advanced solar panels, fuel cells, or even nuclear power sources to ensure a consistent and reliable energy supply. Keeping humans in the loop, telepresence and oversight. While AI-driven probes and drones offer unparalleled autonomy and capabilities, it's important to remember that they are ultimately tools designed to extend human reach and knowledge. Telepresence, the use of remote-controlled robots to interact with distant environments, provides one way for humans to stay involved in the exploration process. Imagine scientists on Earth using virtual reality headsets to control robotic avatars on Mars, exploring the Martian surface and conducting experiments as if they were physically present. This level of control and interaction allows for real-time decision-making and adjustments to mission parameters based on new discoveries or unexpected challenges. AI ethics among the stars, navigating moral considerations. As we entrust more and more autonomy to AI-driven probes and drones, it's essential to address the ethical considerations surrounding their decision-making processes. As we develop more sophisticated AI systems, it's crucial to engage in open and honest discussions about the ethical implications of their actions, and to develop guidelines and safeguards to ensure that these machines are used responsibly and for the benefit of humanity. Today's pioneers. Current projects in AI-driven space exploration. The future of AI-driven space exploration is already being written. Numerous projects and research initiatives around the world are pushing the boundaries of what's possible with autonomous spacecraft. NASA's Mars rovers, for example, are equipped with increasing levels of autonomy, allowing them to navigate hazardous terrain, select targets for scientific study, and even perform some tasks without direct human intervention. The European Space Agency, or ESA, is developing a mission concept called Heracles, which would use AI-powered robots to assist astronauts on the lunar surface. Private companies are also playing a significant role in advancing AI-driven space exploration, with SpaceX developing its Starship spacecraft, designed to be fully reusable and capable of transporting humans and cargo to Mars. To infinity and beyond. The future of AI in space. The future of space exploration is inextricably linked to the advancement of artificial intelligence. As AI systems become more sophisticated, capable of handling increasingly complex tasks, They will unlock new possibilities for scientific discovery and human exploration. Imagine probes venturing into the atmospheres of gas giants, drones mapping the icy plains of Europa or Enceladus, and robots constructing the first human outposts on Mars. With each passing day, we are pushing the boundaries of AI, expanding its capabilities and developing new ways to utilize its power to unravel the mysteries of the cosmos. As we venture further into the unknown, guided by the light of AI, we carry with us the spirit of exploration, the thirst for knowledge, and the unwavering belief that the universe holds endless wonders waiting to be discovered.